Hi guys, how are you? I hope you all are well. So today we are going to see the electric field of a non-conducting cylinder which is uniformly charged, and there is a rho. Rho is what? Rho is volumetric charge density, right? So what we'll do here, we'll see the field of non-conducting cylinder. We'll see inside. Already we have done for outside in the last video. So what we'll do here, we'll take one cylinder like this. So we have a cylinder of radius capital R and the length L, right? So what we'll do, this is the axis, so we have to find the field at this point P, right? Okay, so what we'll do, we'll again create a imaginary cylinder. Why we are doing this? Actually, we want to find the field at this point by using the Gauss law. What is the Gauss law? Gauss law says that flux leaking out of any surface is equal to Q by epsilon. Okay, where Q is the charge, epsilon naught is the permittivity of space, right? Okay, so now we will focus only this charge. We know that this is non-conducting body, right? But we are not going to find out the total charge of this body. We will find out the charge only of this body. I mean this imaginary cylinder. Let us suppose the radius of this small cylinder is R, small r, and the length is capital L. So obviously the field will be like this. Yes. So field will be like this, and the area vector will be like this. This is the area vector, right? So there is an angle between the angle between the field and the area is how much? Theta is equal to 0 degrees, right? Because the field and the area is both are in same direction. Now what we will do? Conventional law for the flux is E dot A. So we have to find, first of all we have to find the charge of the cylinder. So this is the cylinder, inside cylinder, right? So radius is R and the length L. If rho is the volumetric charge density, then the total charge of this cylinder will be volume into volumetric charge density. Okay, what is volumetric charge density? It is the charge per meter cube. Means if I say I have 1 meter cube of volume, let us say we have 1 meter cube of volume, 1 meter cube of volume I have, and the charge of this is 10 coulombs. Charge of this particular cube is 10 coulombs. So I will say the volumetric charge density of this cube is 10 coulomb per meter cube. Okay, right? I hope you understand this. Okay, now so volume is how much? This is the area, pi r square, and this is the length. So length into area, this is volume, right? So pi small r, this is small r, pi r square L into rho, right? Okay, now the area we have to take this small cylinder. Why? Because the flux leaking out of this surface only, right? So now we will see the Q is how much? Pi r square L into rho by epsilon is equal to E is how much? E have to find. A is how much? This pi r into L. It is 2 pi r, so 2 pi r into L. It means this area, this surface area we have to find. What is the surface area? This is 2 pi r. This circumference is 2 pi r into length. So area, outside area will be 2 pi r l, right? Small l it is. Okay. So now we can write 2 pi r l, right? Pi and pi will be cancelled. L and L will be cancelled. And one r will be cancelled here. So we can say E is equal to rho r by 2 epsilon. Rho r by 2 epsilon, right? So we will see here, this is constant, this is constant. Sorry, not 1 minute. Sorry. So E is equal to rho r by 2 epsilon, right? Here you see this rho is constant for a particular body. This is constant, this is also constant. So we can say field is proportional to the r. It means the field generated by the cylinder inside this, it will be proportional to r. Means as you move away from the center of this cylinder, the field will increase. As we have seen in the last video, the field decreases. Field decreases as we go outside. So if you want to make the figure for this, we can make figure. Let us take, this is cylinder. This is cylinder like this. Okay. Okay. So field on the y-axis, distance on the x-axis. So up to inside, it increases. At the center it will be 0. If you keep the value r is equal to 0 here, you will get how much? 0 field. So field here is 0. If you keep r value capital R, so you will get how much here? Field is rho capital R by 2 epsilon naught. But as you move away from this, the field is indirectly proportional to r. I mean, it is inversely proportional to r, and he is proportional to r here. Okay. So now this was the field of a non-conducting cylinder inside. In the last video we have seen the outside. So now in the next video we will see for the sphere. Okay. So okay, thank you so much. Have a nice day. Bye.